Welcome to Algebra 1, Unit 6, Lessons 11 and 12, Practice Problems. Select all true statements about the graph that represents y equals 2x times x minus 11. So they are giving us the equation in factored form. So to find the x-intercepts, which is what A, B, C, and D are referencing, we need to take each factor and set it equal to 0. On the first one, we'll divide both sides by 2, and we find out x equals 0. So the first intercept is at the origin, 0, 0. The other factor, we would add 11 to both sides to eliminate it on the left, and we have x equals 11, so the other x-intercept is at 11, 0. This matches B, so A is wrong, C is wrong, and D is wrong. Next, we're trying to find the x-coordinate of the vertex. The x-coordinate of the vertex is halfway between the two intercepts. So we're going to add the x-intercepts together and divide by 2. 11 divided by 2 is 5.5. So that means H is correct, E, F, and G are wrong. So the correct answers for this first practice problem are B and H. If you have any questions about how to find x-intercepts or how to find the x-coordinate of the vertex, please use class time to ask for further clarification. Select all equations whose graphs have a vertex with x-coordinate 2. Option A, our x-intercepts first we would need 2 because 2 minus 2 is 0. Then we would need 4 because 4 minus 4 is 0. Then if we want the vertex x, it's halfway between 2 and 4, which is 3. And we want an x-coordinate of 2, so A is wrong. On B, the x-intercepts, first we would need 2 because 2 minus 2 equals 0. Then we would need negative 2 because negative 2 plus 2 is 0. So to find the vertex x, that's halfway in between. The vertex will have an x-coordinate of 0. We want an x-coordinate of 2, so B is incorrect. Choice C. The x-intercepts, the first one will be 1 because 1 minus 1 is 0. The second will be 3 because 3 minus 3 is 0. The vertex x is halfway between 1 and 3, which is 2, and that's what we're looking for. So choice C is a correct answer. Choice D. The first will have to be 0 so that x equals 0 and y equals 0. So that puts us at the origin. The second will be -4 because -4 plus 4 equals 0. The vertex x is halfway which equals -2, but we don't want -2, we want +2. So D is wrong. And finally, E. The first x-intercept, we set x equal to 0, and we have the origin. Then we would need 4 because 4 minus 4 equals 0. The vertex x is halfway and halfway puts the x coordinate of the vertex at 2, which is what we were looking for. So on this practice problem, the correct solutions are C and E. If you have any question about how to find x-intercepts and the x-coordinate of the vertex, please use class time to ask for further clarification. Determine the x-intercepts and the x-coordinate of the vertex of the graph that represents each equation. So in the first one, we set x equal to 0, meaning the intercept is at the origin. Then we set x minus 2 equal to 0, add 2 to both sides, x equals 2, so the intercept is at 2, 0. The x-coordinate of the vertex is halfway, and halfway between 0 and 2 is 1. So the x-coordinate of the vertex is 1. On the second one, we set x minus 4 equal to 0, add 4 to both sides to eliminate it from the left, x equals 4, so the intercept is at 4, 0. Then we set x plus 5 equal to 0. Subtract 5 from both sides to eliminate it on the left. X equals negative 5. So the x-intercept is at negative 5, 0. The x-coordinate of the vertex is halfway between 4 and negative 5. So the x-coordinate of the vertex is negative 1/2. And finally, we set negative 5x equal to 0. Divide both sides by negative 5 to eliminate it on the left. And x equals 0. So we have an intercept at the origin. Then we set 3 minus x equal to 0. Add x to both sides to eliminate it on the left. 3 equals x, so the intercept is at 3, 0. The x-coordinate of the vertex is halfway between. So that means the x-coordinate of the vertex is at 3/2. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Which one is the graph of the equation y equals x minus 3 times x plus 5? This is factored form. And factored form allows us to find the x-intercepts by setting each factor equal to 0 and solving for x. So on the first one, we add 3 to both sides to eliminate it from the left, and we get x equals 3. So we know we're going to have a point where it crosses at x equals 3. So when we plot that, we already know that graph A is wrong because it does not cross through x equals 3. And we know that D is wrong because it does not cross through x equals 3. Next, we have x plus 5, and we'll set that equal to 0. Subtract 5 from both sides so that we eliminate it from the left. And x equals negative 5. So we're going to have an x-intercept at negative 5, 0. When we plot that, now we can see that even though graph B did have an x-intercept at 3, it does not have an intercept at negative 5. So B is wrong. But graph C has the first x-intercept at x equals 3 and the second x-intercept at x equals -5, so graph C is the correct answer. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. What are the x-intercepts of the graph of y equals x minus 2 times x minus 4? First, I can set x minus 2 equal to 0, add 2 to both sides to eliminate it from the left, and x equals 2. So my intercept is at 2, 0. Then I can set x minus 4 equal to 0. Add 4 to both sides to eliminate it from the left, and x equals 4. So I know that my other intercept is at 4, 0. Number 2, find the coordinates of another point on the graph. Show your reasoning. Well, I know that the vertex the x-coordinate is halfway between 2 and 4. So the x-coordinate of the vertex is 3. Now I can substitute 3 into the equation to solve for y. And I find out that y equals -1. So now I know the x-intercepts, 2, 0, and 4, 0, and I know the vertex is at 3, -1. Number 3 wants me to sketch a graph. So my first point will be my x-intercept at 2, 0. My next point will be at the intercept 4, 0. And my vertex will be at 3, -1. As long as I have 3 points, I can draw the vertex and the x-intercepts, and that gives me the parabola. If you have any questions about how to find x-intercepts, about how to find the vertex, or about how to sketch a graph with 3 points, please use class time to ask for further clarification. Here are 4 graphs. Match each graph with a quadratic equation that it represents. So, number 1, we have parabola with vertex at origin. That's graph B. So graph B matches number 1. Choice 2. This is a parabola that has been shifted up 5 units. We see that right here on graph D. So that means graph D matches equation 2. Equation 3. This is a parabola that has been shifted up 7. So if we look, we see that right here on graph C. So graph C matches equation 3. And finally, choice 4. This is a parabola shifted down 3 units. And we can see that right here on graph A. So graph A matches equation 4. What you need to take away from this is that adding or subtracting adding to the equation shifts up, subtracting shifts down. So when you see plus 5, that shifts up 5 units. When you see plus 7, that shifts up 7 units. And when you see minus 3, that shifts down 3 units. If you have any questions about what vertical shifting of a quadratic equation looks like, please use class time to ask for further clarification. The two equations y equals x plus 2 times x plus 3 and y equals x plus 2 plus 5x plus 6 are equivalent. Which equation helps find the x-intercepts most efficiently? If I want the x-intercepts, I want factored form. So y equals x plus 2 times x plus 3 is factored form and gives x-intercepts most efficiently. All I have to do is set each factor equal to 0, and it tells me the x-intercept. Number 2, which equation helps find the y-intercept most efficiently? If I want the y-intercept, then I want standard form. Y equals x squared plus 5x plus 6 is standard form, and gives y-intercept most efficiently. Because the number by itself is the y-intercept. If you have any questions about how to use factored form to find x-intercepts or standard form to find y-intercepts, please use class time to ask for further clarification. Here is a graph that represents y equals x squared. On the same coordinate plane, sketch and label the graph that represents each equation. In number 1, the only change is minus 4. This shifts down 4 units. So all we have to do is go to each point and shift it down 4 units. And then you can draw your parabola. Number 2, we have the negative flips upside down, and we have the plus 5 shifts up 5 units. So now I want to go up 5 units, and then I want to start flipping it upside down. And I draw my parabola. So, remember, negative in front of equation flips upside down. Adding shifts up. Subtracting shifts down. If you have any questions about how to flip the graph upside down or how to shift the graph up and down, please use class time to ask for further clarification. Select all equations whose graphs have a y-intercept with a positive y coordinate. A is in standard form, so the number only portion is my y-intercept. So this is -2, so it does not have a positive y-intercept. B is also in standard form. What you don't see is a +0 for your number portion. 0 is not a positive number, so B is not a correct answer. C is factored form. This is x minus 1 times x minus 1. This becomes x squared minus 2x plus 1, and our y-intercept would be positive 1. So C is a correct answer. D is in standard form, so the number only portion is the y-intercept. We can see that it's negative, not positive, so D is incorrect. And finally, E, if we use the FOIL method, becomes x squared plus 3x plus 2. The plus 2 is the y-intercept, so that is positive. So the correct answers to the last practice problem are choice C and choice E. If you have any questions about how to identify the y-intercepts, please use class time to ask for further clarification.